Section 3.3 is pretty short. We really just have one set of definitions that we need to look at, and we need to talk about the difference between elements and compounds. A lot of people use these words interchangeably, but moving into chapter 4, we really want to be able to make note of the difference between these two things as we start focusing our energy on elements and then later on compounds and naming systems. So an element can't be broken down by chemical means. It's in its simplest form. Examples of elements include things like hydrogen, oxygen, nitrogen, carbon, phosphorus. These are probably just the most common ones. We can't break these down any further chemically. They're in their simplest form. The smallest divisions of matter that retain their chemical properties. So there are smaller divisions like neutrons, protons, and electrons, but those do not have any chemical properties, at least that we can identify at this point. So hydrogen, oxygen, nitrogen, carbon, phosphorus, all still maintain their individual chemical properties. If we break it up any lower than that, then we're into subatomic particles, which are not easily observed. Compounds are made of two or more elements. Things like CO2, H2O are examples of compounds. These can be broken down, obviously, because they are made of elements. CO2 can be broken down into carbon and oxygen. H2O can be broken down into hydrogen and oxygen. Even something like N2, which is considered a compound, it can be broken down further. Nitrogen comes as two atoms bound together, but we can still break these apart and break them down into individual nitrogen atoms. So this would be considered a compound. It has the same composition. Now, it doesn't necessarily have to be something like N2, where it's made of exactly the same thing, but it's saying I could take a sample of H2O from one container and a sample of H2O in another container, and what I would find is both of those are made of two hydrogen and one oxygen. A sample of CO2 is always made of one carbon and two oxygen. If we're looking at it in terms of a diagram at a molecular level, these are called particulate diagrams because they show us what happens to each of the atoms or each of the individual compounds. So we're looking at something like element X, and maybe we can call element X oxygen. Then we have element Y, and we can call element Y hydrogen. So we can see that these are two individual elements. They can't be broken down any further and keep their same chemical properties. In the middle here, we have a mixture of elements X and Y, or in other words, elements H and O. So these two are put in the same container, if you will, but they are not chemically bound to each other. Once we get to the point where they are chemically bound, we're talking about a compound. So that's the difference here. It's a mixture, but a mixture in the fact that they are chemically bound to each other. They are actually attached to each other. So in this case, we have compounds of elements X and Y, which means we have an oxygen and two hydrogen. So this would be an example of a water molecule because we have here H2O. So in the middle, this would look different because we have oxygen and hydrogen mixed together. And on the left, we can see a very different sampling of an independent group of oxygen atoms and an independent group of hydrogen atoms. So this is just to show the difference between individual elements and compounds. Remember, elements exist by themselves. Compounds are chemically bound to at least one other atom.